All right. Greetings, YouTube. Beautiful mind here. I hope everyone had a rejuvenating and restful weekend. Let's see. So this will serve as the lecture for week 5, Monday. So we had exam 2. It was due this past Saturday. Okay. So, you know, just make sure that you're getting your assignments in. Turn this down. Let me see. I can't think of any other other real announcements. This week I just want to go through 9.1 to 9.4. I don't maybe 9.5. So like today I just want to do section 9.1. Be on the lookout for a quiz sometime this week. Again, all assignments are due this Saturday. We're going into week 5, so we're past the halfway mark. Okay, so I couldn't update the grades over the weekend. My internet was out, so I will get those in as soon as I can. Probably, just as soon as I can. Okay. So let's just kind of get into the lecture for today. Let's see. We should be able to go. Is that not going to work? So we're going to move into chapter 9 with roots and radicals. And we're going to start with section 9.1, evaluating square roots. Let's see. Guess not. So some objectives here are to evaluate square roots of real numbers. We want to recognize that not all square roots represent real numbers. Determine whether the square root of a real number is rational or irrational. And we want to write square roots as exponential expressions. So let's take a look at evaluating square roots. When we square a number, we multiply the number by itself. For instance, if a is 5, then a squared is going to be 5 times 5, which is 25. If a is negative 5, then a squared is going to be negative 5 times negative 5, which is positive 25. To find the square root of a number, we consider the opposite. So it's kind of like we work backwards. If we know the square of a number, then what is the number? For example, if a squared is 25, then what are the values of a? A could either be, 5 or negative 5. So the positive or principal square root of a positive number is written as a square root of a. The negative square root of a number is written as negative square root of a. So the square root of a equals b if b squared equals a. Also, the square root of 0 is 0, written as the square root of 0 is 0. Okay, I'll let that be. This symbol is called the radical sign. The number or expression inside the radical sign is called the radicand. So the radical sign is a symbol, the little house or this symbol here. This is the square root symbol. And the radicand is the expression inside the radical. Another part of the radical expression is the index. It tells the root of the expression. Square roots have an index of 2. So when we write the square root of x like this means the square root of 2. Right? So we typically don't write the 2. Sorry, this means the square root of x. We typically don't write the 2. But if there's it could be like cube root or fourth root and so on and so on. Okay. See, yeah, that's what I didn't want to happen. Okay. So we have some examples here. We're asked to evaluate. Like the square root of 49 is 7 because 7 times 7 is 49. And you can see all the rest of them, right? Let's see if we can get one where the answers are not showing. So all square roots do not represent real numbers. Consider the square root of negative 9. In order to evaluate the square root of negative 9, we'd have to have two numbers that multiply by itself to give us negative 9. But we don't have any real numbers that do that because positive 3 times positive 3 is positive 9. Negative 3 times negative 3 is positive 9. So we don't have any real numbers that multiply by itself to give us negative 9. Yeah, I don't know why it shows this way. Indicate whether the radical expression is real or imaginary. So notice with this first one, you're just doing the square root of 16 by itself. The square root of 16 is 4 because 4 times 4 is 16. Then we're going to say negative 1 times 4 is going to give us a negative 4. Here with the negative on the inside, there's no real number that multiplies by itself to give us a negative 16, so that's imaginary. Notice we got another negative inside the radical, so that's imaginary. This is a real number, but it's not a perfect square, right? It's going to be some decimal, some irrational number that multiplies to give us 43. So it's going to be some negative real number. It's not a perfect square, but it is a real number. Okay. Let's see. So to determine whether the square root of a real number is rational or irrational, to help our discussion of rational and irrational numbers, we define perfect squares. The numbers 1, 4, 9, 16, 25, so on and so on. These are called perfect squares because each number is the square of a natural number. When a perfect square is a factor of a radicand, we may refer to it as a perfect square factor. Let's see. Okay. A rational number is a number that can be written in the form a over b, where a and b are integers and b is not 0. Irrational numbers are numbers that are not rational, are called irrational numbers. So a rational number is a number that can be written in the form of a fraction, where a and b are integers and the denominator is not 0. Okay. I don't know why, but every time I sit at the desk, my sinuses go haywire. Like I'll be fine any other time, but then when I sit at the desk, it's just like eyes start itching, nose starts watering. I'm like, man, this happens like nearly every day. Only when I sit at the desk though. Like, and it's all in the same room. That's the thing that's so strange about it. I think I just don't want to be looking down. Oh, I think it's like psychosomatic, but it's I'm sure some other stuff too. But okay, let's keep going. Let's sit to the next one. So imaginary numbers are going to be the square root of negatives, and then rational numbers are going to be fractions, integers, whole numbers, natural numbers. Let me see. Natural numbers, whole numbers, rational numbers, integers. And then irrational numbers are going to be the square roots of non-perfect factors, or not perfect squares, or whatever. And then imaginaries are going to be square root of negative numbers. Ugh. Use a table to determine whether the following square roots are rational. Yeah, they're showing it in a way where I can't just scroll. I have to. That's okay. So again, this is a real number, but it's irrational because it's not a perfect square. This is a perfect square because this is 14 times 14. Not a perfect square. And then, again, there's a table on page 554 that can help with finding the perfect squares. Okay. So we can write radical expressions as in exponential form. So for instance, the square root of something is the same as that same thing to the power of a half. All right. So square root as an exponential is going to be to the power of a half. So these didn't display properly. Okay. So I'll just write these out since you can't really see them. Ouch. So the square root of 2 is going to be the same as 2 to the power of a half. The square root of 7y is going to be the same as 7y to the power of a half. 13 times the square root of z is the same as 13 times z to the power of a half. I guess you don't need the parentheses. But you have to know that that half only applies to the z. So, written like this. The half the half only applies to the z. And then in this next one, we have 5 times the square root of 3w. That's going to be 5 times 3w to the power of a half. Okay. So then in this first one, we have 13 to the power of a half. Yeah, you can see it there. All right. Actually, it still didn't display properly, so let me write it out. So the first one was 13 to the power of a half, becomes the square root of 13. The next one is 2c to the power of a half, and that becomes the square root of 2c. This one is 6d to the power of a half. This becomes 6 times the square root of d. And this one is 8 times 3pq to the power of a half. And that becomes 8 times the square root of 3pq. Okay. Let me see. So yeah, like if we were in person, what I would do is I would take the rest of the class time to allow you to work. So I'll go ahead and load some assignments for this chapter on Pearson. Again, be on the lookout for a quiz this week, and I'm available, if you have questions on how to work this. But what's best to do is work on Pearson, and as you have questions, make use of the Ask My Instructor button. There's a button next to each question has an explanation right there next to it. So when you have a question on Pearson, if you're stuck, click on the question help. They'll explain every question. You can also make use of the Ask My Instructor. And with that button, it'll send me a screenshot of the very question you're working on, and it'll send it to my email. I'll load it to my tablet, and I make dedicated YouTube videos walking you all through. Okay, so I hadn't really. I mean, it seems like most people are kind of finding their way, so I just kind of let that be. The main thing is just to get our assignment submitted on Pearson, and yeah. And on that note, we're going to end the session here. And for one beautiful mind to another, enjoy the rest of your day.